In this video, I want to review how to solve exponential logarithmic equations. Those are the equations where you see logs or exp, and maybe you're just stuck when you see it. Don't be afraid. I like to give very straightforward steps which usually work very well, even though you don't have to follow them. So, steps to solve logarithmic and exponential equations. Step 1. When you see log or exp, isolate them. Basically move them to one side. If you work with logs, you remember you can collect them together using properties of logs, laws of logs. Step 2. Apply exponential or log for both sides. So if you're working with logs, then you apply exps. If you work with exp, then you apply log. That makes sense to get rid of it. Then use definition of exponential logarithmic functions, which is y equals log base ax equals a to the y equals y. As you can see, a is the base and stays the base. X will show up, or y will show up on the left or right hand side. Or e to the ln x equals x and ln e to the x equals x. Those are properties of inverse functions. Then solve for x. When you finish solving for x, maybe using quadratic equations or anything, there's an extra step if you work with logs only. Check the domain, because log exists only for positive inputs. Example 1. ln x equals 1 minus x minus 1. I can see two logs, so I'm going to move them to the left-hand side. Then, using laws of logs, I'll have ln x times x minus 1 equals 1. That means I use it log plus log equals log of the product. Now step 2, apply e to the both sides. E to the log gives you just input. Input is whatever you see in the brackets. X times x minus 1 equals e to the 1. Now, this is a quadratic equation, x squared minus x minus e. Move everything to the left-hand side. And quadratic equation has a solution, you know it. X equals 1 plus minus square root of 1 plus 4e all over 2. That gives you two solutions, 1 plus and 1 minus. Approximately 2.229 and approximately minus 1.2229. Extra step is here only for equations which started with log. So go back and see, I see log at the beginning, so I have to check the domain. I need to make sure that these two answers in the boxes make sense. From the beginning, if you look back, I see there's a log of x of minus 1, so x minus 1 should be positive. Then x should be greater than 1, but I have one solution, which is x1. x2 is negative, so it's not in the domain. If you plug it back, it will not make sense. It will be log of the negative number. So I need to cross away one of the roots. So actually only x1 is the good solution here. One more example involving exponential functions where those steps I just gave you do not work. Usually they actually work really well, just collect everything on one side. But if you have e to the 2x and e to the x, you see that they are repeated. So maybe let's change them and call them t, because e to the 2x is actually e to the x squared. So if e to the x is t, then e to the 2x is t squared. T squared minus 4t plus 3 equals 0 is a quadratic equation. You can find roots as t minus 3 times t minus 1 equals 0. You have two solutions, but t is e to the x. So I will have e to the x equals 3 and e to the x equals 1. Now you use one of the steps where you apply log for the both sides, which gives you x equals ln 3 and x equals 0. So you have two answers, ln 3 and x equals 0. For the second part, I wanted to mention, you don't have to actually use log for the both sides. You can just logically ask yourself, e to the what power gives you 1, e to the 0 gives you 1, so the solution is 0. For the first part, that's a typical example when you actually use log for the both sides. To reveal what my x is, to solve for x, to isolate x, I'm using properties of inverse functions. So exponential will be undone by logarithm, so I'm using log for both sides. ln of e to the x equals ln 3, so x is ln 3. For examples like this, you don't have to check the domain because we started with exponential functions, and x can be anything in this case.